With increasing number of people traveling abroad, driving in a foreign country is almost a must-have in our lives. Imagine you are driving in an unfamiliar country. How do you feel if you see these traffic signs? And what about this? Our motivation comes from the situation that tourists have got to recognize traffic signs in order to comply with the traffic rules. However, when the traffic signs in different countries vary in words, shapes, and patterns, it is not easy for tourists to understand them. In this case, they will be very nervous to drive, and they will also face the possibility of violating traffic rules or accidents caused by unfamiliar traffic signs. So, our main goal is to build a mobile app that can help recognize traffic signs so that users can easily learn the traffic rules in different countries. One solution could be traffic sign redesign. For example, adding English instructions or using more intuitive images to guide visitors to understand it. But this solution often requires more manpower and material resources, and it is even more unsuitable for regions that don't take tourism as the main industry. We might also expect smart cars to solve the issue. Even though today's smart cars have sensors to detect objects, but on one hand, most of them can only detect driving speed signs and traffic lines. On the other hand, they are too expensive to produce and still have a long way to go before reaching the public market. This is another motivation for us to design the technology which can be transplanted to the mobile app so that almost every user who owns a mobile phone can easily and quickly recognize any traffic signs they don't know, no matter where they are in the world.
Let's talk about our work. We choose German traffic sign dataset, which include 43 classes and over 50,000 images. Before we start training our model, we initially apply two pre-processing steps to our images. We achieve color normalization and convert our three-channel images to a single grayscale images. By applying deep learning model to this problem, we create a convolutional neural network model to classify traffic signs, learn to identify the most appropriate features for this problem by itself. The CNN is composed of three convolutional layers. Kernel size starts from the 3 multiple 3, with a deep doubling at next layer, using ReLU as the actional function, each followed by a 2 multiple 2 maximum polling operation. The last 3 layers are fully connected, with the final layer producing 43 results computed using the softmax activation function. We mainly tried 3 multiple 3 and 5 multiple 5 filter size to train our model, and start with the depth of the 32 of our first convolutional layer. For evaluation, we decided to use accuracy and the loss score to compare. However, this picture shows that there's no obvious difference between the two sides. In order to increase the accuracy, we normalized our images. We compared color vs grayscale, standard and normalized images. The picture shows the accuracy score increased after the normalization on the color and the grayscale full dataset, and the best score is 93% from color images. Moreover, we observed some erratic loss behavior on the validation set after a given number of the epochs, which actually meant our model was overfitting on the training set and not generalizing. So we decided to use dropout to improve the model reliability, which is a form of regularization where weights are kept with a probability p. The unkept weights are dropped. This prevents the model from overfitting. We defined 2 levels of dropout, 0.75 for convolutional layers, 0.5 for full connected layers, which enabled us to achieve a test set accuracy of 96.98% on normalized grayscale images, which can define our model works pretty well. To summarize, how we approach the problem and explore the deep learning technique to better solve a problem is meaningful to us. Methodologies we developed during the project, normalization and optimization we played with, technical problem and the challenge we faced are all what we learned and benefit from this project. In the future, we will work on the image augmentation or historical equalization to optimize our dataset and achieve a better accuracy score. And thank you for watching.